Hello everyone. In this video we're going to try to solve this triangle with the given information. If we do a quick sketch to see what type of scenario we're dealing with, if we go ahead and call this angle A, then we know the side opposite A, and we know one other side which we can just, without loss of any generality, consider to be this side. So we can just put B equals 10.9 meters here. So this is a scenario where we know two sides and an angle that is not between them. So if you recall, this is called the SSA scenario, which is also known as the indeterminate case, because these, depending on the size of this opposite angle, may either end up with no triangle if this side is not long enough to reach this side here, or you may end up with a situation where you have two possible triangles, one where it can fall this way and the other where it can fall this way. Or you may have just one triangle possible in the case where it's exactly the length of the height. So let's go ahead and drop a perpendicular here to find the length of the height of this triangle if it were to exist. So we can quickly measure the length of the height by finding the sine of 44.5 degrees, because that will be opposite over hypotenuse. So we get h over 10.9. So if we go ahead and cross multiply, we get h equals 10.9 sine of 44.5 degrees. Now, if you go ahead and calculate that, this is a rather long problem, so I went ahead and did the computations, otherwise this video would take too long. If you go ahead and verify on your calculator, you'll notice that this is approximately 7.6. Now, if we look at this, that means that the value of h here is less than the value of a, which is 8.9. Let me go ahead and put a first, which is also less than the value of b. So that means the side opposite angle A falls somewhere between H and B. That means there's two possible cases. One is A could fall like this, because we know it's bigger than H, so it can go like that. But since it's less than B, it can also fall this way. So A is somewhere between the altitude as far as length and the other side. So we know we're going to have two scenarios. So we're going to go ahead and use the law of sine. So let's go ahead and do one potential situation here with A being 8.9, just so that we can get a feel for how we're going to set up the law of sines. So we know that sine of A over A equals sine of B over B. So notice in this equation here, we know capital A, we know lowercase a, and we know lowercase b. So capital B is the only unknown. So we're going to go ahead and solve for sine of B. So we have A sine B equals B sine A upon cross multiplication. So we get sine of B equals B sine A over A. So now if we substitute, we get sine of B. It's always a good idea to solve algebraically and then substitute. You minimize the chances of making errors. So we get 10.9 sine of A, which is 44.5 degrees, over lowercase a, which we know is 8.9. Okay, so if this is sine of B, that means B must be the inverse sine of that. So we have B equals the inverse sine of 10.9 sine of 44.5 degrees over 8.9. All right, so we go ahead and carefully plug that into a calculator, and let me go ahead and show you that one just in case. All right, so let's go ahead and clear everything. So we have, so we make sure we are in degree mode. Then we go ahead and hit second sine for inverse sine. Now we're going to go ahead and put the numerator in some parentheses. So we have 10.9 sine of 44.5 degrees. We need 2 of those, and then divided by 8.9. We should be done with that. All right, so we get approximately 59.1 degrees. But remember, if the sine of an angle is a certain value, the sine of 180 minus the angle is also the same value. So what we're going to do now is we're going to find, that's how we end up with 2 triangles. So we're going to go ahead and do 180 minus 59.1, and we get 102.9. So, or it could be 102.9 degrees. All right, so notice that we have 2 scenarios here. We have one triangle which looks like this. Let me see if I can do a better job here. Well, here is A, here is B, here is C, and we know that this is 44.5 degrees, and the angle B is going to be 59.1 degrees. Now C we can find very quickly by just doing 180 minus 44.5 minus 59.1, and we get 76.4 degrees. That's one possible triangle, and we have another one where the angle B is going to be actually larger than 90. So it's the one where, as we mentioned, it's going to swing this way, the side opposite angle A. So this time we have an angle looking like that. So B will be 120.9 I'm sorry, 102.9. Let's check. 120.9. So and then we have 44.5 degrees here. So now we can also find C again very quickly. So it's going to be 180 minus 44.5 minus 120.9. So this time we get 14.6 degrees for our C. Okay, so this is how we end up with two scenarios. So in each one, we already know certain values, correct? We know, for example, A is 8.9, and that goes for both of them. The size of A doesn't change. And B also does not change. B is 10.9 in both of them. I'm not putting the meters in, you know they're there. So just trying to save some time here. So 10.9. And the only real unknown, given that we have already found the angles C in both of them, is going to be the side C. So, and we can quickly get the side C by applying the law of sines again. So we know that sine A over A equals sine C over C. Of course, we do that because we're trying to find lowercase c, so we want to use that particular ratio. So let's go ahead and solve for C first. So we have C sine A equals A sine C. So C equals A sine C over sine A. So if we plug in now, we get 8.9 for A sine of this C in this particular case, which is 76.4 degrees, over sine of A, which is 44.5 degrees. Now, when we do this, there's no inverse. This is easier, so we're just going to type 8.9 sine of 76.4. We're going to close those two parentheses, and then we're going to get divided by sine of 44.5. So we end up with approximately 12.3 for C in this case. So this one is fully solved, because remember, a triangle is fully solved if you know all three angles and all three sides. Now we'll do exactly the same for this other scenario, so we don't have to go through all this again because we've done it. So we're going to use this fact that C is A sine C over sine A, again with different values. A, of course, remains the same, 8.9. Sine of C is different. C is this time 14.6 degrees. And we're going to divide that by sine of A, which also does not change. So sine of 44.5 degrees. All right, so when we calculate this time, all right, so this time we get 8.9 sine of 14.6, and we're going to divide that by sine of 44.5 degrees, and when we do, we get approximately 3.2. So we always have to make sure things make sense to us. So here, I mean, it's approximately equal to, we can just, for the sake of simplicity, just put equals. Of course, you know, these are approximations. All right. So does it make sense that this side is less than this scenario? Of course, because notice the opening of this angle is much less than this angle. So it makes sense that this side would be larger than that, given that these two sides are not changing. All right, so now this one is also fully solved, and these are our two possible cases. And this always happens after we calculate the height and we realize that the side opposite the angle A falls somewhere between the measure of the height and the other side. So one way it can swing is this way and the other is this way, creating two possible triangles. All right, so make sure that you fully understand that and try one on your own from homework. That should really get it solidified in your mind. All right, so be safe until our next video.